This is ELC131, Circuit Analysis 1, and we'll finish up our discussion of power by looking at resistor power ratings. Now, the maximum power that can be dissipated by a resistor, also referred to as the resistor wattage rating, it tells us that resistors can fail or degrade if they're too hot over a period of time. And what we mean by degrade is their value of resistance will change. The maximum power dissipation that's allowed for a particular resistor is determined by 1, the physical size of the resistor, 2, the construction material, and 3, the ambient temperature, where this term ambient means the temperature of the surrounding air. Now, the standard values that we have for resistors are 1/8 watt, 1/4 watt, 1/2 watt, 1 watt, 2 watt, 5 watts, and then there's no particular numbers after these. It kind of depends upon the design that we can buy specialized resistors with higher power ratings. Now, generally speaking, the larger the size of the resistor, the more power it can dissipate. And this is because the larger size equates to more surface area. The larger the surface area of a resistor, the more air molecules the resistor touches. Therefore, it's easier for the resistor let me restate that, it's easier for thermal energy to be transferred to these surrounding air molecules. So we look at figure 1, it shows us a series of 20 ohm resistors. All these resistors have the same value of resistance in ohms. However, notice starting from the left to the right, the resistance rating goes from 2 watts down to 1/8 watt. Showing us that the power rating of a resistor is determined by its physical size. Now, resistor construction also plays a role in the maximum power dissipation of a resistor. Generally speaking, the 1/8 to 2 watt resistors are either carbon composition, carbon film, or metal film. However, we can have metal film resistors that are rated up to 5 watts. For high power applications, we will use wire wound resistors, and these can be rated up to hundreds of watts. Now, ambient temperature also plays a role. The greater the ambient temperature, the harder it is to transfer this thermal energy to the surrounding air molecules. So at temperatures above 70 degrees Celsius, we must derate the resistor. And what this means, for example, at approximately 110 degrees Celsius, we must derate the power rating to 50% of the stated rating. In other words, if we have a resistor that would be dissipating 1 watt of power at 110 degrees, we would need to use a 2 watt resistor for this application. So reviewing, the resistor wattage rating is determined primarily by the physical size, but it's also determined by the material. And we have to take into account the ambient temperature for derating considerations. And when we look at purchasing resistors, the standard values for resistor power ratings are 1/8, 1/4, 1/2, 1, 2, 5 watts. And again, when we look at high power applications, we select resistors such as 10 watts, 20 watts, 50 watts, 100 watts.